Let's get to look at the assignment for quadratic functions which was given. If alpha and beta are roots of the quadratic equation x squared minus 3x minus 5 is equal to 0, find the quadratic equation that has got roots alpha minus 3 and beta minus 3. Now, before you are able to find the equation that has got these roots, you look at the equation that you've been given. You need to find the sum of alpha plus beta and the product alpha times beta. So if we say alpha plus beta, we know that alpha plus beta is given by negative b over a. And then alpha times beta is given by c over a. If we look at the function x squared minus 3x minus 5, b there is the number that is in front of x. So we're going to say negative, where there is b, we're going to put negative 3. And then a is the number in front of x squared, which is a 1. So this is going to give us 3. C is the constant from what we are able to see from the equation, and that is negative 5. A is the number in front of x squared, which is a 1, and so alpha times beta is going to give us negative 5. Now I want to find the equation that has got the roots alpha minus beta and alpha minus 3 and beta minus 3. How do you do it? That is for part 1. The first thing is we need to find the sum of the two roots that we have been given. And the sum, we are going to simply get alpha minus 3, which we've been given. We add plus beta minus 3. So this is going to give us alpha minus 3. I can distribute the positive plus beta and then minus 3. I'm going to put the letters together, so that will be alpha plus beta, and then negative 3 minus 3, that will be negative 6. Now we know what alpha plus beta is. We have already found that alpha plus beta is a 3, so we're going to put a 3 there, and then minus 6, and this is going to give us a negative 3. Another thing we need to find is the product. So product, simply get alpha minus 3, the same two factors which you've been given, or same two values you've been given, or roots, and then beta minus 3, multiply them. So here we're going to do cross multiplication, alpha times beta, and then alpha times negative 3, that will be negative 3 alpha, and then negative 3 times beta, that will be negative 3 beta, and then negative 3 times negative 3, that is going to be positive 9. And this is going to give us alpha beta. Let me factorize out a negative 3 on these two. So I'll set negative 3. What are we going to remain with? We are going to remain with alpha plus a beta. That is what we've remained with. And then remember at the end we have got a 9, so plus 9. Where there is alpha beta, we are going to substitute negative 5. That is the product. Then minus 3. Where there is alpha plus beta, we are going to substitute 3. And then plus 9. This is going to give us negative 5 minus negative 3 times 3, that is 9, plus 9. So these two cancel, so the answer is going to be negative 5. Therefore, to find the equation, we found the sum and the product. The equation is given by x squared minus sum x plus product is equal to 0. So that will be equal to x squared minus, what is the sum that you have found? It's here, negative 3. And then we put x at the end, and then plus product we have found negative 5. This is equal to 0. We just simplify. This will be x squared. If we distribute these two negatives, it gives us positive 3x. Positive times negative, that will be negative 5, is equal to 0. So this is the equation for the first one. And then same way with the next one, we are going to find the sum and the product. So the sum then is going to be 1 over alpha plus 1 plus the other factor we've been given is 1 over beta plus 1. What are we going to get from here? When we are adding fractions, you can get what is down, multiply with what is on top of the first one. That is going to give us beta plus 1. And then multiply what is down with what is on top of the second one. That will give us plus alpha plus 1. And then divide, now multiply the two denominators. So alpha times beta, that will be alpha beta. alpha times 1, that is alpha, 1 times beta, that is going to be beta, and then 1 times 1, that is going to be a 1. Where there is alpha times beta, I can as well put these together like that. Now, before I put them anyways, I can just proceed first and simplify. So here I'm going to put the letters together. I can start with the alpha and then write the beta. I can even put them in brackets and then plus. If I add here the 1 plus the 1, that is going to give us a 2. We are going to divide in the denominator. We're going to have alpha beta plus, I'm going to put alpha plus beta and then plus 1 at the end. So our aim is to make sure that we have got something in the form of alpha beta, and then we have got alpha plus beta, because we know the value for alpha plus beta, we know the value for alpha times beta. That is the aim of everything that we are doing. And now we substitute in our values. Where there is alpha plus beta, we're going to substitute 3, so that will be 3 plus 2 on top, divided by where there is alpha beta down, we are going to substitute what is alpha beta. We can say that is a negative 5, and then plus where there is alpha plus beta, that is a 3, and then plus a 1. And this gives us 5 divided by negative 5 plus a 3, that's a negative 2, plus a 1, that will be a negative 1. And so the answer will give us negative 5. And then we need to find now the product. Product, get also the two factors again, 1 divided by alpha plus 1, multiply by 1 divided by beta plus 1. And that is going to give us, on top if we multiply 1 times 1, that will be 1. Down if you multiply alpha plus 1 times beta plus 1, we are going to get alpha beta plus alpha plus beta and then plus 1. Now we go on and substitute in our values. This is going to be 1 over, where there is alpha beta, we substitute, that is a negative 5. Plus where there is alpha plus beta, we know that is a 3, and then plus a 1 at the end. So this is going to give us 1 divided by negative 1, which is equal to a negative 1. Now to find the equation is given by x squared minus sum, you put x, and then plus product is equal to 0. So this is going to be x squared minus, what is going to be this? The sum. We have already found the sum here to be a negative 5. And then we put x there, and then plus the product, which is a negative 1, and this is going to be equal to 0. So meaning the equation is x squared plus 5x minus 1 is equal to 0. So that is how we get to work that one out. And then the last one on this question, you want to find the equation given the roots 1 over alpha squared plus 1 and 1 over beta squared. So first, finding the sum of the roots, we are going to get 1 over alpha squared plus 1 over beta squared. And this is going to be multiply what is on top of the first fraction with what is down the second fraction. That is going to be beta squared plus alpha squared, and then we multiply the two denominators. That will be alpha squared multiplied by beta squared. I can start by writing first alpha squared on top, and then I write the beta squared. What is down, I can also write it as alpha, beta, and then I put a squared outside. Think of it, if I have got 2 squared multiplied by 3 squared, this is the same as me simply multiplying 2 and 3 and then raising this to the power 2, because they are all raised to the same power. So that is what I've just done in the denominator. Now every time we have got alpha squared plus beta squared, we need to know we have to substitute an identity there. And the identity is alpha plus beta in brackets squared minus 2 alpha beta. And then divided by, in the denominator we have got alpha beta and then squared. Now we can go on and substitute. Where there is alpha plus beta, we are going to substitute. We know the value for alpha plus beta, that is 3. But remember that is squared. And then minus 2, where there is alpha times beta, that is negative 5. And then we divide that by, where there is alpha times beta, that will be negative 5, but we are squaring this. That is going to give us 9 plus 10 divided by 25. So this is going to be 19 divided by 25. So that is our sum. Now we find the product. So the product is going to be 1 over alpha squared multiplied by 1 over beta squared. And this is the same as 1 over, if we multiply alpha squared and beta squared, is the same as getting alpha beta with a squared there. So this is going to be 1 divided by, we know alpha beta is negative 5. So we're going to square this, and that is going to give us 1 divided by 25. Then to find the equation, we know it is x squared minus sum x plus product, and that is equal to 0. So this will be x squared minus the sum is 19 divided by 25. Attach x. The product is 1 divided by 25, and that will be equal to 0. So this is the equation, but if I want to do away with the fraction, I'm going to multiply this by 25. So 25 times x squared, that is going to be 25. That is going to be 25 x squared minus 25 multiplied by 19 over 25. The 25 will cancel, that will be 19x. Even 25 times 1 over 25, then 25 will cancel, that will be 1, and that is going to be equal to 0. So this is how it's going to be for this one. If alpha and beta are roots of the quadratic equation, x squared minus x minus 3 is equal to 0, state the values of alpha plus beta and alpha times beta, and find the value of what has been given. So first thing, let's find the value of alpha plus beta. So whether we are finding equations or we want to find just a value, first thing we need to find the sum and the product. So alpha plus beta we know is given by negative b over a. So in this equation, b, we can see the number in front of x is negative 1. And then a is the number in front of x squared, that is a 1. So this is going to give us a 1. And then alpha times beta is given by c over a. We can see c is the constant, that is negative 3. A is the number in front of x squared, so that will be negative 3. Now we can work out the first one, a. Want to find alpha squared plus beta squared. Now remember, we already mentioned every time you have got alpha squared plus beta squared, you need to replace alpha plus beta squared minus 2 alpha beta. So where there is alpha plus beta, we're going to substitute what we have found as a 1, but that is squared, minus 2. Where there is alpha times beta, we replace a negative 3. So this gives us 1 plus 6, and that is going to be a 7. And then for b, we want to work out alpha minus beta squared. As you can see from here, we don't have alpha minus beta, we only have alpha plus beta. So we are going to expand this. Alpha minus beta squared is the same as alpha minus beta, and then alpha minus beta. You are multiplying them twice. So it is different from alpha squared minus beta squared. This is a difference of 2 squares, which gives us alpha plus beta, and then alpha minus beta. Very different. This one is in brackets and then the square. So if we get to multiply these two, we are going to get alpha squared minus alpha beta minus alpha beta plus beta squared. We are going to put these two together, and then we are going to pair up also these two together. So I'll get the alpha squared and put it together with the beta squared. If we add negative alpha beta minus alpha beta, that will be negative 2 alpha beta. Now where there is alpha beta, we now substitute what we know. Where there is alpha beta, we're supposed to put alpha plus beta squared minus 2 alpha beta. Now remember, we have already another minus 2 alpha beta. And so this gives us alpha plus beta squared minus 4 alpha beta. Now we substitute. Where there is alpha plus beta, we are going to substitute 1, and that is squared, minus 4. Where there is alpha times beta, substitute negative 3, and this gives us 1 plus 12, which is a 13. You can answer now the last question on this part. We have got alpha to the power 3 plus beta to the power 3. what is the identity that we use for power 3? So every time you have got power 3, what you write, you are going to have alpha plus beta in brackets, and then you are going to have alpha squared minus alpha beta, and then plus beta squared. So this is the identity that you are going to use. You can prove if it is true. Try to multiply this, the alpha, with what is inside there. You are going to have alpha to the power 3 minus alpha squared beta plus alpha beta squared, and then multiply beta with what is in these brackets. You are going to have beta alpha squared, and then you are going to have negative alpha beta squared, then you are going to have plus beta to the power 3. So from what you can see, alpha squared beta will cancel with alpha squared beta here. Those, no, they are not going to cancel like that. It will cancel with this one, because you can see we have got alpha squared and 1 beta. You have 1 alpha squared and 1 beta, but they have got opposite sides, so they cancel. I mean opposite signs. Also this one will cancel with this one. So you see you end up with alpha squared plus beta squared, which is the same thing we've been given here. So that is the identity that you use every time you've been given something raised to the power 3. And so this is going to be alpha plus beta. Now we are going to pair the alpha squared and the beta squared, and then we are going to now write the minus alpha beta. So this gives us alpha plus beta, and then we have got, we know the identity to use when we have got alpha squared plus beta squared. We use alpha plus beta, this is in brackets, squared, and then minus 2 alpha beta. Now remember, we also have another minus alpha beta there, shouldn't be forgotten. So this gives us alpha plus beta, and then we have got alpha plus beta in brackets, squared, minus 2 alpha beta minus alpha beta, that would be 3 alpha beta. Now we start substituting. Where there is alpha plus beta, we are going to substitute a 1, and then we have another alpha plus beta, that is 1, but it is squared, minus a 3. Where there is alpha beta, that is going to be negative 3. So this is going to give us just a 1 plus 9, which is a 10. So that is going to be the answer for this one. If alpha x squared minus 8x plus 2 is equal to 0 as a repeated root, find the possible values of a. What do we mean by repeated root? It means that it has got equal roots. For example, imagine you are solving a quadratic, you found that x is equal to 2, and then you find again that x is equal to 2. So this is a repeated root. So there are conditions that we have to know. When you find two different roots, it means that the discriminant b squared minus 4ac is greater than 0. Two different roots. If you find two roots which are the same, it means that b squared minus 4ac is equal to 0. So that means there are two equal roots. And then for that equation, if you can't find any roots, it means that b squared minus 4ac is less than 0. So no real roots, or two complex roots. So you don't have any real root, but you have got complex roots for this condition. Now for this one, we've been given that you have got repeated solutions. So it means this is the one we are going to use. Okay, repeated solutions means that you have got equal solutions or equal roots. So I'm going to say b squared minus 4ac is equal to 0. In that equation, b is a number in front of x, that is negative 8. We square that, minus 4. A is the number in front of x squared, and that is a. And then c is a 2. This should be equal to 0. Negative 8 is squared, that is positive 64. Negative 4 times a times 2 to be negative 8a, and that is going to be equal to 0. I'll take the 8a the other side, it becomes 64 is equal to 8a. Divide both sides by 8, a is going to give us 8. So that is the value. For the next one, given that the quadratic equation alpha or a x squared plus bx plus c is equal to 0, where a cannot be equal to 0 has got two roots, a and b. Given that a is negative b minus c, square root of b squared minus 4ac over 2a, and b is negative b plus square root of b squared minus 4ac over 2a. Show that the sum of the two roots is alpha plus beta is equal to negative b over a. So this is just direct. We've already been given that alpha plus beta, we want to show that it is negative b over a. Okay, we want to show that it is negative b over a. We also need to show that the product of the two roots is going to give us c over a. Now, we know from our knowledge to say, how do you find the sum alpha plus beta? We know that alpha plus beta is given by, of course, this is the statement that we use already. So the statement has already been given, but that's the one we want to show. So then how are we going to move? We can actually move the opposite direction, but let me take a shorter path. So the equation that we have is a x squared plus bx plus c is equal to 0. And you've been given that the two roots, you have got alpha, which has been given, and beta, which has also been given. Okay, so we've been given alpha, we've also been given beta. So I'm going to say x is equal to, now just think of it. Okay, let me first write that. Now instead of having x, what we have is alpha. So alpha has been given as negative b minus square root of b squared minus 4ac divided by 2a. Now, maybe before I get to confuse anything, let me first remove this. Already we've been given that this equation has got roots alpha and it has got roots beta. Let's take it as though they've not given us these values. Let's take it as though they've not given us those two values. Then how do you work out? So already we know when you are solving a quadratic equation which has got x, it means that the values is going to be x is equal to alpha or x is equal to beta. Where are these coming from? You've already been given. It has got two roots, alpha and beta. So it means that after we solve this equation, these are the two values that we are going to be able to find. That's the meaning. Now take note of this equation which is here. I'm not using it. All I'm doing is I'm just working with the roots that have been given. So we know that for us to find that x is equal to alpha and or x is equal to beta, how was it? It was x minus alpha and then x minus beta is equal to 0. All I'm doing is taking the beta this side, it becomes negative, the alpha this side becomes negative. You can try. How do you solve this? Equate this to 0, equate this to 0. You're going to find that x is equal to alpha or x is equal to beta. From here, I'm going to multiply x times x, that is x squared, x times negative beta, that is negative beta x, and then negative x times x, sorry, that is negative alpha times x, that is negative alpha x, then negative alpha times negative beta, that is positive alpha beta, and that is going to be equal to 0. So this gives us x squared. I'll factorize out a minus. What am I going to remain with? This is negative, so they will both remain positives. Now let me start with the alpha and then write the beta. I'll also factorize out x, but let me put x at the end here, and then plus the alpha beta, that is equal to 0. So these two equations should be the same. Why? Because these roots we used here are actually coming from this equation, from the equation that you've been told. So meaning we now compare coefficients. Coefficient of this one, we can see here the coefficient of x squared is what? A 1. So what I'm going to do is I'm going to make this one the coefficient of x squared being a 1. So I'll divide through by x by a. So divide by a throughout, so that will give us x squared plus b over ax plus c over a, and that is going to be equal to 0. So we can now see the coefficient of x squared is equal to the coefficient of x squared. It means that the coefficient of x should be equal to the coefficient of x. So what is the coefficient of x here? It is b plus over a. That should be equal to the coefficient of x here. What is it? It is negative alpha plus beta. If I want, I divide now by this negative. Then I'm going to have alpha plus beta is equal to this negative will now go on here because I've divided by it. So alpha plus beta will now become negative b over a. And then we can also compare the product. This is the product. It should be equal to the product from this equation. In other words, this is a constant. It should be equal to the constant in that other equation. So this gives us that alpha times beta is equal to c over a. And those are the two that we have been given. Those are the two things that you've been given. But apart from you taking this root, since we already been given what alpha and beta is going to give us, we just want to show that the sum alpha plus beta is going to give us negative b over a. So all you do is alpha plus beta. What is alpha? They've already given us alpha, that it is negative b minus square root of b squared minus 4ac divided by 2a. We are adding beta plus, what is beta? Beta we've been given negative b plus the square root of b squared minus 4ac divided by 2a. Now the next thing, we need to just add these two equations. Now you can see the denominator is the same, so simply write one big line, put the 2a, and then add the powers. So that will be negative b, not the powers, sorry, add the numerators, negative b minus b squared minus 4ac, and then you have got also, this is a negative b, right, and then plus the square root of b squared minus 4ac. From what we can see, this one and this one will cancel because it's the same thing, but they have got opposite signs. What will just remain is negative b minus b, and that will give us negative 2b. Down, remember, we have got 2a. So the 2 cancel with the 2 there, that will give us now negative b over a, and that is what we've been given, so hence shown. And then now we find the product. Product alpha times beta, simply get alpha, which is negative b minus square root of b squared minus 4ac divided by 2a, and then multiply by beta, which is negative b plus square root of b squared minus 4ac, and then over 2a. So multiply now these two. You are multiplying what is down with what is down, what is on top with what is on top. So if I multiply the two denominators, we are going to get 4a squared. If we multiply the numerators, negative b times negative b, that is going to give us positive b squared. Then negative b times this term, we are going to have negative b square root of b squared minus 4ac. And then negative this root times negative b, we are going to have positive, our first write b, and then the big root b squared minus 4ac. And then if I multiply this negative of the root and negative of the root, we can okay, the only difference is that these are positive and negative. So the first thing is it will be negative, the answer will be negative. But look, what is inside the root is the same as what is inside the root here. When you are multiplying the same thing which is inside, you simply get that same thing which is inside if you have got two roots. So if you multiply root of b squared minus 4ac times the root of b squared minus 4ac, you simply get b squared minus 4ac. So that is what we are going to get. Now already we can see this and this is the same, so it will cancel out. And then we just simplify this. Now what remains, that will be b squared. I'll distribute this negative, that will be negative 4ac. And then negative times negative 4ac, that will be, so that is supposed to be first negative b squared before I can write. So that will be negative b squared, and then negative times negative 4ac, that will be positive 4ac, and then divided by 4a squared. So from here we can see this will cancel with this, 4 will cancel with a4. 1a here will cancel with 1a there. 1a is going to remain. So we're going to remain with c over a. Hence shown. So there is the product.